Hey guys, welcome back to Genius Learning. Today I want to show you something that I struggled with when I was taking calculus, implicit differentiation. And so I found a very simple method to handle these types of problems. So let me show you how I take care of these, okay? We got to take the derivative, right? So we got to find dy dx, okay? And when we're doing implicit differentiation, we have two variables that we need to watch out for. So every time that we take the derivative of y, so every time that we do y prime or the dy dx, okay, we need to write dy dx next to that derivative, even after we took it. So let me show you what I mean. Okay, so we have an x and a y, so we need to do product rule, okay? So I'm gonna leave this 3 out, okay? And this is the product rule. We got f times g, and so the product rule is f prime g plus f g prime, okay? So I labeled x as my f times y, which is my g. All right, so I'm pulling the 3 out, and then I'm gonna do the derivative of x squared first, which is my f prime, so 2x, and then the g comes along, so y to the 4th. Okay, I didn't take the derivative of y. So remember, only when I do the derivative of y do I write dy dx. So for now, I just did f prime. G came along, plus, now my f comes along, and here, which is my g, we take the derivative, but this is y. So let's take the derivative, which is 4y, and then 4 minus 1 is 3 on top, times dy dx. All right, I'm gonna circle that here. So every time you take the derivative of y, you write dy dx after. Okay, so I'm gonna put that in parentheses. This entire thing is just the product rule of this. Now let's go here, where we have to do another product rule because we have x and y together. And so I'm gonna take the minus sign out so we don't get confused. And now this is gonna be my f, and secant y is gonna be my g. Okay, so I'm gonna take my f first, take the derivative of it, so that's gonna be 4x to the 3rd. Okay, the g, which is secant, comes along. Okay, and then we have plus, the f comes along, and we have to take the derivative of g prime, which is secant. So the derivative of secant is secant tangent. And since we took the derivative of this, we need to do the chain rule, right? And we need to put dy dx. So dy dx, because we took the derivative of y. Secant had a y in it, and so taking the derivative of this thing, we have to write dy dx after the term. Okay, this whole thing here is only for these two, and now we still equal -4, but taking the derivative of a constant, that's gonna be 0. All right, so now let's see what we have. We have dy dx, and that's the goal, right? We have to find that, so we have to single it out. So let's try to put both of those on one side of the equation and everything else on the other side. Okay, so this term here can stay, and this term here can stay. Remember that we have to distribute this 3 into the first one and distribute it into the second one. Okay, so if we distribute to the second one, there's already a 4, so 3 times 4 is going to be 12. We got x squared, we got y to the 3rd, and we have dy dx. All right, I'm just going to keep circling that. And then if we distribute this 3 into here, it's going to make a 6, right? And we want to put this entire term on the other side of this equal sign. So it's going to be a positive 6xy to the 4th. When I take this over to the other side of the equal sign, okay, I'm going to have a -6 x to the x y to the fourth. All right, so I just put that on the other side of the equal sign, change the sign. Now, what do I got left? I have this term, right? That needs to go to the other side because it doesn't have a dy dx. So when I distribute this negative into the first term, I'm gonna get a negative 4x to the third secant y. I wanna take that and put it on the other side of the equation, the equal sign. And so if it's a negative here, it's gonna be a positive on the other side. 4x to the third secant y. And then we're just left with this term. So if I distribute this negative into this term, it's gonna stay negative because we're leaving it on the left side of the equal sign. And I'm just gonna rewrite everything here. So we got secant to the y, tangent to the y, and then we have dy dx. Right? Perfect. So now let's take out dy dx from both of these terms. So we have dy over dx. And here we have 12x squared y to the third, which is this term, minus x to the fourth, secant y, tangent y for the second term. And then this still equals the same thing. We haven't done anything to it. So I'm just rewriting it. Okay, and since I want dy dx by itself, let's divide this entire thing down to the bottom of this side. And so finally, we're gonna have dy dx equals this top part. So negative 6x y to the fourth plus 4x to the third secant y divided by everything here in this bracket. We're gonna take this whole thing and just divide it to the other side as a whole. So I'm gonna keep the bracket. This first term is 12x to the second. We got y to the third. And this is x to the fourth secant of y tangent of y and close bracket. Okay? So this right here is what we were looking for. So our objective is to just watch out. Every time we take the derivative of y, we need to write dy dx right after that term. And wherever we have an x and a y, we need to do the product rule. Okay?